Hello everyone. Today we're going to be talking about motion along a straight line. We're going to be explaining average velocity, average speed, and the difference between them. So stay tuned. But first, Assalamu alaikum. I welcome you to FIAM Math, providing physics and mathematics tutorials for secondary level and beyond. Make sure to subscribe so you can easily find all the lessons that you might need and to write down any requests you may have on the comment section so they can be added in future videos. Now, when we say motion along a straight line, we mean motion in only two dimensions. And one of those dimensions is width and the other is time. But first, let's talk about width. If I have a particle, at the beginning of its movement, it was at this point here, then this point here will be 0. Here I will have x and negative x. So 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, and negative 5. So this particle, when it starts motion along this straight line, either goes right, or it goes left. And so whenever this particle is undergoing a motion, we're going to have two values for x. We're going to have the x1, which is the position where it started, and x2, the position where the movement has ended. So let us say that the particle x was in 2 when it started its motion and went along until it reached 3 or it reached 5. So x1 equals 2, let's say meters if x is by meters, and x2 equals 5. But what is the distance that this particle covered? The distance that this particle covered is going to be delta x, which is the difference between x2 and x1. So it's going to be 5 minus 2, which equals 3. Now, if this particle started at 3 but ended at negative 2, or started at 2 but ended at negative 2, in this case x1, so let's make this the first case. In the second case, x1 equals 2 meters, while x2 equals negative 2 meters. Delta x is going to equal x2 minus x1. x2 is negative 2 and x1 is 2, which equals negative 4 meters. So delta x here is now negative 4. And now that makes sense, because when we're talking about distance here, distance is a vector quantity. And a vector quantity has both magnitude and a direction. So in the first example, the distance equals 3 in the positive direction, which is the right hand side or the right hand direction, while negative 4 means that the particle has moved in the negative direction or the left hand direction. And this concept is called displacement. This is the concept of displacement. If an object or a particle moves from one point to another point, the difference between those 2 points is the displacement of this object or particle. Now, with something like displacement at hand, now we can start talking about average velocity. The average velocity of any object, well, if this object has made a displacement, it's going to make it in an interval of time. It's going to take time to do so. It's not going to just disappear in one place and appear in the other. And so, if you take the difference in displacement divided by the difference in time, this will give you average velocity. And average velocity is a vector quantity, which means it has a direction as well as a magnitude. So if you have a particle that has a displacement, or let's just take the previous displacements here. In the first one, it had a displacement of 3. In the second one, it has a displacement of -4. So let us say that both of them took about 2 seconds. So for both for both 1 and 2 in the previous example, let us say that time delta t equals 2 seconds. So if I want to find the velocity for both of them, well, I just have to divide the delta x by delta t. Delta x is, for the first one, is 3. So for the number 1, average velocity is going to equal 3 divided by 2, which equals 1.5 meters per second. For the second one, displacement was -4, so it's going to be -4 divided by 2, which means the velocity, the average velocity, was -2 meters per second. And because velocity is a vector quantity, from just seeing the answer here, you can tell that those two velocities were in opposite directions, because one of them is positive in the positive direction and the other one is in the negative direction. Now, taking average velocity to be delta x by delta t, delta x equals x2 minus x1, and delta t equals t2 minus t1. This looks very much like the rule of the slope of a straight line. So if I'm going to represent this motion in a graph, we know that slope is y2 minus y1 by x2 minus x1. So in the y-axis, I'm going to have the position. So in the y-axis, I'm going to have x, and in the x-axis here, I'm going to have the time, and so I'm going to have t in the x-axis. So I'm going to have x versus t, or position versus time, with the origin point being 0 for position and 0 for time. If I have a movement that looks like this, a motion that looks like this, and I want to find the average velocity for this motion using this, all I need to do is find the slope of this curve. But we're talking about an average velocity. We're not talking about a velocity at a certain point. So all I need to do is If I want to find, for example, the average velocity between point 1 here, so here let's call this x1, and the second point, let's make it here, this is x2. Of course, I'm going to have now time t1. I'm going to have t2. If I want to find the average velocity between them, all I have to do is just connect a straight line between those 2 points, find the gradient or the slope of this straight line, and I have my average velocity. So here, slope equals average velocity. This area here represents delta t, while this area here, or sorry, this segment or this line here represents delta t, while this line here represents delta x. And so by finding rise over run or delta x by delta t, I will be able to find my average velocity for this period of time. All right, then what about average speed? And what is the difference? Now, to put it in simple words, average speed describes just how fast the thing is going. While in velocity we focus on the direction of the movement. In speed, all we have to do is just focus on uh, the distance covered by time, regardless of what is the direction of the movement of in that distance. In velocity, we deal with both the distance covered, the time, and the direction, while in average speed, all we need to care about is how fast the thing is going. And so in average speed, we can say it's just total distance, regardless of its direction, by total time, or by delta t, because delta t is the same in both of them. Now, because average speed does not include direction, um, average speed is always positive. Average speed can never be negative. So if we go for the last example here, the average speed, if we again take the time interval to be 2 seconds, the average speed here is going to be total distance covered, which is 3, divided by 2, which is 1.5, just as the velocity, by the way. But for this one here is going to be a bit different. Now I need to calculate the total distance covered, so it's going to be 1, 2, 3, 4, not negative 4. Total distance covered is just 4, not negative 4. We're not talking about displacement. The displacement is negative 4, but we're just caring about the total distance covered. Now the total distance covered can be the absolute value of displacement itself. However, we just can come here and see that it's just from 2 to 1, that is 1 meter, from 1 to 0, that are 2 meters, from 0 to negative 1, 3 meters, from negative 1 to 2, that's 4 meters. And so the average speed is going to be 4 divided by 2, which equals 2 meters per second. No negative sign, because we're just talking about total distance. So from the example, let's just write it here from the example. For number 1, total distance is 3 and time interval is 2, which equals 1.5 meters per second. For number 2, total distance is 4 and time interval is 2, so 2 meters per second. Now, would that make a difference between velocity and time? Yes. The difference between velocity and time can also be in magnitude. It doesn't just have to be in the direction itself. For example, let us say that I have a movement here that goes like this. I have a body that moved, went from, let's say, a person got in their car, went from their house to the shop, bought some things, and then hopped in their car and came back home. So here, this is x1. Let's say that this is here is 1 meters, 2 meters, 3 meters, 4 meters, 5 meters. Okay, let's just make it up to 4. Okay, and we have here time. Let's make it in minutes. So here, this is 60 seconds, 120 seconds. Or let's just make it in minutes. So 30 minutes or 0.5 hours, 1 hour, 1.5 hours, 2 hours, 2.5 hours, and here let's say for 3 hours. All right, so this is x, the position. Let's make it in kilometers, and this is time in hours. So if I want to find the average velocity and the average acceleration from this point here, let's say that it started the movement at this point and ended the movement at this point here, they're going to be totally different. Let us see. Now, the average speed equals total distance by the time interval. Okay, what is the total difference? So it moved from 1 up to 4, and then again from 4 back to 1. From 1 to 4, it's 4 minus 1, which equals 3. And again from 4 to 1, it's 3. So for the, this is average speed, not average velocity. The total distance that this person covered is 6 kilometers. And the time that he took is 3 hours. And so the average speed is going to be 6 divided by 3, which is 2 kilometers per hour. Now let's see the average velocity. Now in average velocity, we take the displacement. So this is going to be x1 here. This is the point where he started the movement. This is x2, the point where he ended the movement. So x2 minus x1 divided by t2 minus t1. Now x2 is 1 and x1 is also 1 because he pretty much started and ended the motion at the same point. So x2 is 1 meters and x1 is also 1 meters, and time is 3 minus 0.5. Okay, I made a mistake here. It's 3 minus 0.5 here again. So it's 2.5, it's divided by 6, 6 divided by 2.5, which equals 3.6 kilometers per hour. So here, um, it's the same thing. 1 minus 1 equals 0, and this equals 2.5. 0 divided by 2.5 equals 0 kilometers per hour. Now here the average velocity is 0 kilometers per hour, while the average speed is 3.6. Why? Simply because in average velocity, we pay attention to direction. And this person has went in the positive direction, but then he came back in the negative direction the same amount of displacement that he went in the positive direction. Or to make it more simpler, he started and ended at the same point in displacement, so the displacement is actually 0. He started and ended at the same position, so the displacement is actually 0. So according to velocity, this person did not move from their place. They just went and came back. So by the end of it's not like they did not move at all, but the starting position is the same at the ending position, and so there is no displacement at all. And that sums up the difference between average speed and average velocity. You can see that sometimes, for example, in a movement like this, you might need to be dealing with speed so you can find uh, information about the movement, because if you use velocity, it's not going to come up with anything. But mostly in most movement, whether it was in 2 dimensions or 3 dimensions, uh, velocity is the one that is always used in physics, because velocity simply provides you with both the direction and the magnitude of the movement itself. Now here we have an example to finish with. We have a car that moves uphill. I'm just going to write the short version of on the example. The car moves uphill at 40 kilometers per hour and downhill at 60 kilometers per hour. We want to find the average speed for the round trip. So S average for the whole round trip. The average speed equals the total distance divided by the time taken, or delta time. So we have total distance by delta time. Now what is the total difference? The total difference for the whole trip is the distance that the car traveled when going uphill plus the distance that the car traveled when it was going downhill, divided by the total time is also going to be delta t1 plus delta t2. And in both cases the car moved the same distance, so distance 1 equals actually distance 2. So we can just, for both of them, say D. Now, but the time is not the same. The time is not the same because when it was going uphill, it was going slower than when it was going downhill. So the first speed when it was going up, let's call it S1, it's going to equals distance divided by delta T1. And the second speed when it was going down, again, equals distance by delta T2. So the average speed equals d plus d divided by d by delta t1 plus d by delta t2, and d plus d equals, let's just make it here, 2d. I'm sorry, there is a step that I skipped. I have to find delta t1 and delta t2. So delta t1 equals d divided by the first speed, and delta t2 equals d by the second speed. Now I can substitute and say that the average speed equals d plus d equals 2d, delta t1 equals d over s1, and delta t2 equals d divided by t2, because time, sorry, s2, because time equals distance by speed itself. Now just by dividing everything by distance, 2d by d equals 2, d by s, d equals 1 over the first speed, and then 1 by the second speed, which equals 2 divided by, now the first speed is 40 kilometers per hour, the second speed is 60 kilometers per hour. Adding the fractions, 40 and 60, 120, so 3 plus 2, so it equals 2 multiplied by 120, 2 by 0 is 0, 2 by 2 is 4, and 2 by 1 is 2 divided by 5, which equals 48 kilometers per hour. And we can do the same thing for if we have velocity instead of speed, because they're basically the same rules. You always have distance over time, so you can do this with velocity the same way. But anyways, we'll stop here. That will be it for this lesson. Thank you. Don't forget to subscribe so you can easily find all the videos you need, and to write down any request that you might have in the comment section so they can be added in future videos. Thank you, and see you next time.